Hello friends, in the previous video we have seen theory related to the shear force diagram and bending moment diagram. Here we are going to solve the problem on SFD and BMD. See the problem. Draw shear force and bending moment diagram for the beam shown in figure. You can see this diagram. Just draw this diagram. This one is point A. At point A, support is given. You can see this support, that is RA. Here you can see 500 Newton load is acting on this point. At this point, the load is acting, that is 1000 Newton. From this point to this, uniformly distributed load is given, that is UDL. The intensity of that UDL is 200 Newton per meter. You can see here. This point to this, the distance is 2 meter. From this point to this, distance is 2 meter. From this point to this, the distance is 4 meter. B point is given. At point B, the vertical support is given. You can see this vertical support. Here you can see that support. The total distance of a beam, that is 8 meter. And we have to draw shear force and bending moment diagram for a given beam. See, first of all, you have to draw free body diagram. Means you have to convert this UDL into point load. We know that how to convert UDL into point load. And after that, you have to solve this problem. The step number 1 is to calculate support reaction. Already you know how to calculate support reactions. See here, by applying the equilibrium condition, summation of a moment at point A is equal to 0. Here we are taking clockwise as a positive. You can consider anti-clockwise as a positive also. But throughout the problem, the condition should be same. Here we are taking clockwise positive. So we mentioned the clockwise as a positive, means anti-clockwise negative. As per your choice, you can consider. Here you can see this reaction RA is passing through the same point, passing through the point A. So there is no perpendicular distance. So the moment will be 0 for this RA support, RA force. Now this 500 Newton about point A, this 500 Newton is acting vertically downward. So it will move in the clockwise direction about A. This 500 Newton is moved in the clockwise direction. See the cursor location. See the cursor movement. So clockwise, so positive 500 into perpendicular distance, that is 2 meter. You can see this distance is 2 meter. So 500 into 2 plus, see this 1000 Newton. You can see this 1000 Newton is moving in the clockwise direction. So plus 1000 into 4 plus, first of all, you have to convert this into point load. So 200 into 4, that will be the intensity. So here you can see 200 into 4. It will act downward at the center of UDL. So distance will be 4 by 2, that is 2. So from this point to point A, the distance is 6. 4 by 2, that is 2 plus 2 plus 2, that is 6. So it will also move in the clockwise direction. So plus 200 into 4, that is intensity of force, that is 200 into 4 into distance 6, perpendicular distance 6, minus that RB will move in anti-clockwise direction. So minus RB, this is your B point, and the support reaction, that is RB, is moving upward. So it will move in anti-clockwise direction about A. So minus RB into 8. Perpendicular distance is 2 plus 2 plus 4. Total distance from A point to RB, total perpendicular distance from A to RB, that is 8. So RB into 8 is equal to 0. That is first condition of equilibrium. Here there is only one unknown. After putting all the values in the calculator, you will get the value of RB is in Newton. You will get the answer 1225 Newton upward. Here you will get the value of RB. Now see, once you will get the value of RB, there is only one unknown, that is RA. You have to use another condition of equilibrium, that is summation of Fy is equal to 0. While taking Fy is equal to 0, upward positive, downward negative. In the case of summation of Fy, you have to consider only forces. So Ra is moving towards upward direction, so positive Ra plus Rb. Rb is also moving towards upward direction, so plus Rb. 500 is moving towards downward direction, so minus 500. 1000 Newton is also moving downward, so minus 1000. And this 200 into 4, that is 800 Newton, is moving downward direction. So minus 200 into 4 is equal to 0. Here we have the value of RB from first equation. So you will get the value of RA, that is 1075 Newton. Now we have the value of RA and RB. Means in the first step, we have taken the value of support reactions. We have calculated the value of support reaction. While solving any problem of SFD and BMD, the first step is to calculate support reactions, that is RA, RB, by using condition of equilibrium. You will get the value of unknown, or you can see the value of support reaction. That is the first step. And now the next and very important thing, you can see this diagram. You have to draw a given diagram very perfectly. Here we have support reaction RA. A point is given, B point is also given. 500 Newton is acting at point C. 1000 Newton is acting at point D. From D to B, UDL is given. You have to draw the similar diagram here. And next step is to calculate shear force calculations. That is very, very important. Proportional diagram you have to draw. The values are very important. Unit is also important. Do the correction. All values are in Newton. So answer will be in Newton only. Shear force calculations. Here I am explaining the concept of shear force. You know what is meant by positive shear force and what is meant by negative shear force. Accordingly, you have to put the values here and you will get the answers. See, first of all, you have to start from point A. you have to start from point A. First of all, do one thing, write down for every point shear force at point A just to the left, shear force at point A just to the right. After that, as per the sequence, from left to right, you can write shear force at point C just to the left, shear force at point C just to the right, shear force at point D just to the left, just to the right, shear force at point B just to the left and just to the right. So here you have to write down shear force at point A just to the left, shear force at point A just to the right, shear force after A, there will be a C. So do the correction, shear force at point C just to the left here. See the cursor location, do the correction, shear force at point C just to the left. Again for C, shear force at point C just to the right, shear force at point D just to the left, shear force at point D just to the right, shear force at point B just to the left, shear force at point B just to the right. See the sequence A, C, D, and B. Just to the left, just to the right, just to the left, just to the right. Just at point D, just to the left, just to the right. Again at point B, just to the left and just to the right. Here you can say, you can see shear force at point A just to the left, just to the right. Shear force at point B just to the left, just to the C. Here instead of B, you have to take C. Shear force at point C just to the left. Shear force at point C just to the right. Similarly, for every point A, C, D, and B, you have to write from left to right. Here you can see here. One by one, I will explain. This is a very important problem. So while explaining, the problem will finish in only 30 to 40 minutes. But whenever you will solve this problem first time, at least you will take 1 hour. So see each and every problem very perfectly. Then you will get the idea how to solve. This is a very important problem. At point A, just to the left. Now see the cursor location. Cursor location is very important. I have taken cursor at just to the left and consider all the forces left to the section. You have to consider all the forces. Now there is no any force towards left of the section. So shear force at point A is equal to 0. You can see here, left side of the cursor, there is no any force, no any vertical or you can see the downward force. So shear force at point A is equal to 0. Now come at shear force at just to the right. See the cursor location. Cursor location is very important. And now you can consider the left side forces of the section. Cursor indicates the location of section. Now shear force at point A just to the right. See, RA is moving towards upward direction. So the value of RA, that is 1075 Newton. Make correction, 1075 Newton. It is moving towards upward, so the value is positive. Now after A, the next point, that is C. You can see the point C. Next, shear force at point C. Here do the correction in E content also. Shear force at point C just to the left. Now here, consider all the forces moving upward or downward left to the section. Only RA is moving upward direction. So shear force at point C just to the left is equal to, again, only RA moving upward. So 1075 Newton. Do this correction. Next, shear force at point C just to the right. See the cursor location. Just to the right. Cursor is here. Now consider all the forces left to the section. RA is moving towards upward. 500 kilonewton, 500 Newton is moving downward. So positive 1075 minus 500. You will get answer 575 Newton. All the values are given in the Newton. So answer will be Newton. Do the necessary corrections. Next, after the point C, the next point is D. Shear force just to the left. Now see the cursor location. And you have to calculate shear force at point D just to the left. So you have to consider all left side forces. RA is positive, minus 500. 500 is moving towards downward, so minus 500. So answer will be plus RA minus 500, that is 575 kilonewton. Sorry, Newton. All the values are in Newton, so answer will be in Newton. Make a necessary correction here. Now, shear force at point D just to the right. Now you can see here. See the cursor location just to the right at point D. You can see here. Consider left side forces plus RA minus 500 minus 1000. The answer will be 425 Newton. Now the next, this answer will be minus 425 Newton. So here you have to put a minus sign. 575 minus 1000, the answer will be minus 425 Newton. It is moving towards, the point will be below the baseline, so minus 425 Newton. Now next, B just to the left. Next point, shear force B just to the left. Now see, this point is very important. Consider all the left side forces. RA upward, so RA minus 500 minus 1000 minus the UDL is given. So you have to take minus intensity of that UDL, that is 800. So answer will be minus 1225 Newton. And next point, shear force at point B just to the right. Now you have to consider all the left side forces of the section, all the left side forces of the cursor, plus RA minus 500 minus 1000 minus 800 plus RB. So here the answer will be 0. If shear force just to the right at point B will be 0, then and then only our all the answers are right. So the condition is very important. Make a necessary correction here, minus 425 Newton. All the values are in Newton. That is very important. Now you have to draw shear force diagram. Just extend faint lines here. Draw vertical lines from A, from C, from D, from B point. Just extend all the lines very faint. It will be more easy to draw. So see the value at point A, 0 and 1075 Newton. At point B, the value will be 1075 and 575. So 1075 and 575. At point C, 575 and 425, minus 425. So 575 and minus 425. At point B, it's a minus 1225 Newton and 0. Now just you have to draw the line from 0 to 1075. See, from A to C, there is no any load, so line will be straight. Here, this is a 500 Newton. You can draw this straight line. From C to D, there is no any force. So from C to D, again, there will be a straight line. From this point to this, that is 1000. Already we located the points plus 575 and 420 minus 425 minus, so it is below the baseline. See, the important thing is that from D to B, the UDL is given in the given diagram. So here there will be an inclined line. You can see below the UDL, there will be an inclined line in shear force diagram. That is inclined line 1225 Newton, and you can see this is the RB, that is 1225 Newton. Now the next and very important calculation, that is bending moment calculation. Bending moment diagram is also very important. As already I explained in theory part, bending moment at ends means at point A and at point B will be 0. So at point A and at point B will be 0. Now the next point, that is C. You can see C here. Here you have to use sagging and hogging concept. You can see sagging, that is positive bending moment. So while calculating bending moment at point C, you can see point C here. Just you have to consider only left side. RA moving will move in the positive manner. So 1075 into perpendicular distance, that is 2. The value is positive. So 1075 into 2, 2150 Newton into meter. So the next point, that is point D. You can see the point D. At point D, RA will move in a sagging condition. So 1075 into, from D point, the distance is 2 plus 2, that is 4. So 107.1075 into 4, that is positive, minus 500 will move in the hogging condition. So minus 500 into 2. See, again I am explaining sagging and hogging. Now we are calculating about D, bending moment about D. First force, that is RA. RA will move in the clockwise direction and it is left to the section. So RA into 4, that is positive. But 500 Newton will move in the anti-clockwise direction and it's left to the section. So it is negative, that is hogging bending moment, that is negative. So 500 into perpendicular distance from D, that is 2. So bending moment at point D is 3300 Newton into meter. And as we know that as an end point B, there will be bending moment will be 0. You have to locate at point C, at point D. Now you can see below the straight line of SFD, from A to B, there will be an inclined line. See, below this straight line, there will be an inclined line, but in the bending moment from D to B, there is a parabolic curve. You have to draw a parabolic curve. It indicates that from B to D, there is a uniformly distributed load. See, this is the university problem. Very simple problem is there. The first step is to just calculate support reaction. The second step, just calculate shear force calculation. In the third step, you have to calculate bending moment calculations. We will see the different problems. Just take a university problem. In the next lecture, we will see the another problem. Thank you. Thank you very much.